All right, so this one is number 36 from the homework. This one is secant 4x is equal to 2. So again, I'm going to let u equal the 4x, and this is what I'm really going to work with. And so now I got to look at my triangle, right? So it's 2, 1, root 3, so this would make this one pi over 6, pi over 3. I'm looking for the adjacent side to be a 1, so that means that the reference is going to be pi over 3. Because this is positive, it tells me to draw it in this quadrant. This quadrant and this quadrant for secant, because it's the same one where cosine is positive. So we're really looking at these two. So it is going to be pi over 3 and 5 pi over 3 in that quadrant. So that's what u is equal to. And of course, what was u equal to? U was equal to 4x. Okay, and let's just take a look at the directions once again. They're looking for the solutions between 0 and 2 pi. Okay, so that means that we can't just write a little expression to come up with all the solutions. We actually have to write out all the solutions between 0 and 2 pi. And we know that this is compression. So secant is these little cups that do this, right? And there's usually like, just 2 of them or whatever over a period. But when we squish the graph together, you're going to get more of these little cups inside your, between 0 and 2 pi. So if this is a compression and we're going to have 4 times as many cups, we're actually expecting 4 times as many solutions as we usually have. So if between 0 and 2 pi we usually have 2 solutions, I'm expecting each of these to give me 3 more. I'm expecting 8 solutions overall, like 4 times as many. Okay, so again, we get x is equal to pi over 12, and x is equal to 5 pi over 12. And from here, like if you watch the other videos, there's different ways to do it. But the way that I like to do it, because, we know a lot about trig functions, I know that the period for this function is actually 2 pi over 4, or in other words, pi over 2. So we really just going to be adding pi over 2 to these. That's where the next time is that, like if we're moving across, like if this is 1, then at pi over 2 away, these things will be pi over 2 away. And if this is one of my solutions, right, they'll all be lined up in the same place, then this one will be pi over 2 away. So we'll be able to find them all in our picture, right? And then this one is a different set of ones. So I don't know, wherever those ones would be, maybe here. These will be pi over 2 away. And then, these ones will be pi over 2 away. So when we go pi over 2 away, we'll find the next one that's in the same height, right? So what am I going to do? I'm going to write pi over 2 as 6 pi over 12, since these are in 12. So if I take pi over 12 and add 6 pi over 12, my next one will be 7 pi over 12. Then I'm going to take 7 pi over 12 and add another 6 pi over 12. So I'm just keep adding 6 pi over 12 each time. And that'll put me, at 13 pi over 12? And I keep doing this till I'm bigger than 2 pi, or at least I know that I'm close enough to 2 pi that if I add another 6, I'll be over. So the next one will be when I add another 6, it'll be 19 pi over 12, and then it will be another 6 will be 25 pi over 12. Is that true? No. Oh yeah, 25 pi over 12. And this one's too big, right? That one's bigger than 2 pi. That's what I expected, because I just said I should get 4 out of this side. 1, 2, 3, 4. Those are my 4 solutions from this one equation, right? Now this one I expect to yield me 4 also. So I take my 5 pi over 12 will be the first one. And when I add 6 pi over 12 to it, the next one will be 11 pi over 12. And I add 6 more. And then I add 6 more. Still smaller than 2 pi, but if I add another 6, we know it'll be too big. So here are my 8 solutions between 0 and 2 pi for secant 4x is equal to 2.